Yes, can you hear me?
Yes.
All right. So
same T-shirt as yesterday as well for Louis. Just saying, not the only one.
No, that's a different one. That's a different one. Yesterday was yellow.
All right, since you didn't get to see me yesterday, my T-shirt is clearly new. All right, can you see my slides?
Yeah, we can see it.
Perfect. Okay, now let's see if the sharing works. All right, so I'll drive the slides. Luz and I are going to talk a little bit today about component pack and the underlying fabric, why Docker and Kubernetes are important, and then I'll spend a little bit of time talking about the composition of component pack and how you can start to adopt that, and we'll see how we do in time. I'll drive the slides and I'll hand it over to Luz right away.
Thank you, Andre. So good morning or good afternoon, good evening, everyone. Andre and I, we talk about this presentation, and one thing that we thought it was going to be very helpful for everyone is to get everybody on the same page, or at least try to get some basic knowledge to most of you guys out there that are not very familiar with this whole process of containers and orchestration. And this gives you an idea why this is so important. So I'm going to go through some of the basics, kind of get your feet wet, and then Andre is going to go deeper into the whole component pack deployment overview. Next, please. So we're going to talk about a few things that we believe that is very important for all of you guys to understand, because again, right, if you are going to deploy component pack, if you are going to go, actually some of our other products are also going on this same direction. So it's very important for you to understand every single component. And I'm actually going to give you a couple of additional recommendations of another technology that you might want to get familiar with, for example, like Ansible. Okay, next one. So the first one is containers. So again, I think that many of you know about containers, and I'm not going to spend a lot of time on this one. I only have 8 minutes or 10 minutes, by the way. But if you look at this graphic, I think it's very self-explanatory, right? When you look at containers, what you're doing is that you're basically separating your application or applications from all the operating system dependencies. So what you see on the left, well, let's start with the right. When you see on my right is, basically how you can have multiple applications running on the same, let's say, VM infrastructure. And you see that, you see the infrastructure, you see the Hyper-V, and then each application run on their own, a VM, which means that they have their own operating system, their own set of dependencies, and so on. When you go to the left, now you see a container-based deployment where you move the operating system outside the application layer and you create a new layer that is very much focused on the application itself, right? So at the very end, this gives you a lot of benefits. And if we can go to the next slide, please. This gives you a lot of benefits. Like, for example, you can create applications that are almost operating system independent. So I can develop an application that runs on whatever, right? Because again, at the very end, you separate the application layer from the operating system layer. You can also boot these containers in seconds. So let's say you have an application running on VM, something happened, you need to reboot the whole VM. That's going to take you 10 minutes, 5 minutes, maybe, depending on the VM. When you move that application into containers, you need to reboot that application, or you need to create a new container, because we're going to talk about container registry in a few minutes. But another thing that happens, let's say my VM got corrupted. Oh my goodness, I have to take a snapshot, I have to restore this snapshot. That whole process, we may be looking at probably hours, right? But in the container world, if your container gets corrupted, all you need to do is destroy the container, instantiate a new container, and that literally takes seconds. If much, I would say, most of the containers I have seen, at least for our products, are within the 1 to 2 seconds kind of time frame. As I said before, the the container approach allows for a lot of portability. So you no longer develop applications based on each specific operating system. Now you develop applications based on the cloud native, based on the Kubernetes approach. Now, another thing that's very important is that containers are ephemeral instances, right? So if you're running containers, you have to make sure you use persistent volumes outside the container, because when you run these containers, they are ephemeral. They are supposed to be destroyed at some point in life, right? So when they get destroyed and a new container comes back up, you just have to make sure that all your data, the data that you need to preserve, is sitting outside the container. So when the new container comes back online, or multiple containers, right, need to access the same data, that data is on a persistent volume outside the container. A little bit of history here. Again, Docker is not the only one, so we're gonna kind of focus on Docker, but Docker is not the only container runtime environment. It was the first one, but there are a few others out there. Not that popular, not that relevant in the industry, but they are out there. Next, please. So the other thing that's very important to understand is YAML. Actually, one thing I forgot to mention, can you go back 1 second? Oops, go back. Okay, so I was actually missing a section at the bottom, so sorry about that. It looks like we didn't grab the latest version of the presentation, but the other thing I wanted to mention on this slide is container registry, right? So you will see in a lot of our documentation that you need to update the container registry. You need to update, the images in the container registry. So what the container registry is basically the repository with all the images you use in your deployments. If you guys have played with Docker before, most likely you went to the Docker Hub. So the Docker Hub is a public container registry. If you want to deploy some, I don't know, NGNX, for example, right? If you want to deploy a container with NGNX, you don't have to go from scratch and create the container, install NGNX, and do all that work. Most likely what you do is you just pull an image that already have NGNX running out of the Docker registry, which in this case is the Docker Hub. In the context of ACL Digital Solutions deployments, again, as you go through the documentation, you see that one of the steps in the documentation is to upload the images into your production kind of corporate container registry, right? So for example, let's say that I'm gonna talk completely independent of the connection releases, right? So let's say that connections 8, right, comes around. And you already have connection 7 already deployed. So the way that you would theoretically doing, right, is you just go and upload the new connections 8 images into your corporate container registry. You go into your Kubernetes cluster and you run a Helm upgrade task that basically brings your deployment to the next release, and it brings all the images from the container registry. Another pretty cool thing about Helm and Kubernetes and container registries is that if you deploy, let's say version 10 of whatever, right? And you find that, oh, you know what, I see a problem, I need to roll back. All you have to do into Kubernetes is do a kubectl reverse, right? Or revert is actually, I think is the actual command. So you will be able to pretty much in real time revert any deployment to a previous release. So things like that, again, it's a lot of benefits that Docker, Kubernetes, and Helm charts will give you. So next one, please. Okay, so the other thing that more than a technology is a language that I think is very important for everybody to get familiar with, and that's YAML, right? Most people call it yet another markup language, but it looks like the official definition is that it is not a markup language. But the point about YAML is that we use YAML a lot, and I mean, not we ACL Digital Solutions, but in the DevOps world, everybody uses YAML for mostly configuration files. But another thing that you will be able to use YAML for is when you create Ansible playbooks. And I don't know if Andrew is going to talk about Ansible a little bit in his session, but Ansible is another technology that is very, very important when you want to look at automation. Now, the other thing that's very particular about YAML, and it's probably the one thing that nobody likes and everybody hates, is how case and how sensitive it is to proper indentation. So my one advice, if you guys have to do any manipulation of YAML files, if you have never done it before, use a YAML editor. Because I don't know if you can see on the screen right here, but you see a tiny line that basically shows how the different entries are aligned, because it's not like in XML or JavaScript where you can create brackets and you know that it doesn't matter the position, that bracket, it is what it is, and that belongs to this specific section. In YAML, it's not like that. If I move one line, 2 spaces or 1 space to the right, where it's not supposed to be, right there you get an error. So again, big recommendation, use a YAML editor. Next one, please. Okay, so Ansible. Ansible is a technology which, as I said, I think is very important for you guys to get familiar with. And what Ansible gives you is automation, okay? So just to give you an example, just to give you a story on how I got introduced to YAML. I was on a project about 2 years ago, maybe a little bit less than that, where I had to deploy, a Kubernetes cluster with about 12 different nodes, right? 3 master nodes and a bunch of worker nodes. And on each node, we actually had to do a bunch of tasks, and I had to do the same task over and over and over again on each node. That application was not a real production application, nothing to do with ACL, so don't, no critics. The point is that, I have to perform so many tasks so many times that whole process was probably, 10, 12 days. So we start looking into playbooks and Ansible playbooks, and basically what we did was create a bunch of YAML files. And again, you have to follow the Ansible, you need to follow the Ansible documentation. But what we did was we created a bunch of Ansible playbooks, and a playbook is basically the recipe for how things need to work in that specific order, in that specific sequence. But we created an Ansible playbook where from one machine, from my Mac, from my machine, as long as I had SSH connectivity to all the 12 different nodes I had to work with, from my machine, all I had to do was run one single command. That Ansible command will go and read the playbook and will get one machine at a time. We'll say, okay, I need to go to the master node and install Kubernetes. Okay, now I need to go to the second master node and I need to install admin and add the node. And then I have to go to the other node. And then it went through each of the worker nodes and basically install whatever it needs to install, and then automated the whole configuration. Long story short, we went from a 12 days process to deploy that Kubernetes environment into less than 4 or 5 hours. So again, it's very important. And again, Andre is going to probably mention that a little bit. But if you're looking into deploying hundreds of machines, if you're looking into some type of provisioning or continuous delivery automation, Ansible Playbook is going to be your best friend. Next one, please. Okay, so Helm charts. Helm charts, just to make it pretty simple, Helm charts is the application manager within Kubernetes. I told you a few minutes ago that let's say that we're about to install, whatever new product of, coming out of ACL. If you already have a Kubernetes cluster, the process for you would be upload the images into your container registry and then just basically run helm install app, right? And that's it. And then your app is up and running. Kubernetes is going to realize, again, I'm oversimplifying the process, but Kubernetes is going to say, okay, I'm installing this specific app. I need this many nodes. I need this many pods, blah, blah, blah. So the application is up and running. But that whole process, again, once you have your Kubernetes cluster up and running, that process now takes minutes because everything is already pre-deployed, pre-installed. All you have to do is let Kubernetes know that you want to install that app, maybe on a particular namespace, and then Kubernetes in Helms, what it does is, Helm charts, what they do is bring the images from the container registry, and think about images like templates. That's pretty much what it is. So bring all the images, deploy in the cluster, and that's it. Oh, you don't like the app? You were just playing around? Helm, delete my app. That's it. The app is gone, and every single node that machine required, it's also gone, right? So again, Kubernetes does a lot of the automation behind that. You want to upgrade the app to a new release? Upgrade. I gave you the example before, it's actually rollback, not revert. So if you want to roll back to another release because this one is not stable enough, you just roll back and that's it. And if you want to see the entire history and how many times you have upgraded that app and what versions are actually, somehow available in the container registry, all you have to do is Helm history. So again, Helm charts is the application manager for Kubernetes, and this is most likely what you will be. There are some other things out there that you might be able to use, but Helm charts is what you will have to get familiar, and it's pretty simple to do. And in most of the documentation, most of the instructions you will see, it's literally 2 or 3 lines you will have to run, and that's gonna be it. That's gonna be all your interaction with Helm charts. Next, please. Okay, so again, based on a lot of conversations we have with our clients, sometimes it's not 100% clear what's Kubernetes, why do I need it, kind of what's the benefit and why you guys are moving that route. So Kubernetes is basically containers orchestration. You know what containers are, you know that Docker is the most popular one. So now what you need Kubernetes for is to orchestrate the behavior of these containers. For example, let's say I have 2 apps, right? And this app need multiple containers. What happened is that if one of those containers crash, right? Yes, Docker might be able to reboot and reset that container and create a new one in real time. But what happens if your app is running out of resources, running out of space, or running out of a CPU or compute power? That's where Kubernetes can have auto-scale capabilities. And oops, sorry, can you go back? Yeah, and that's where Kubernetes can actually go back and give you a lot of excuse me, a lot of compute power, because what a Kubernetes cluster is basically a joint effort of compute power, right? So on this machine, what you see that each of these nodes is actually a physical machine or a VM. So remember, a node, so a Kubernetes cluster is a combination of compute power that could be coming from multiple VMs or hardware. Each node, okay, is an actual VM or physical machine. In a production deployment of Kubernetes, you need around 3 master nodes. And the master nodes on top, what it gives you is the control plane. Now, the hardware or the specs that these master nodes need is actually rather small. So maybe, I don't know, 1 gig or 2 gigabytes of RAM and maybe 2 cores, and that's it, because it's always admin work. The number of worker nodes, it totally depends on the application you are deploying. In this case, I show 3 worker nodes, which is 3 VMs, but it could be only 1, or it could be 100 of them. And on the same Kubernetes cluster, I can actually deploy multiple applications, and you usually use what's called namespaces, right? Connections is one app, so it is in the connections namespace. Same time is another app, it is in the same time namespace. And the more applications you deploy, the more workers you will actually have. And actually, Andre, I think you still have the old presentation, so if you let me share my screen, because there is one other slide that you don't have in there. Okay, let me share my screen pretty quick.
Can you just grab it?
Yeah.
I don't know how to stop.
Yeah, I'm doing it.
There you go.
Okay, perfect. So again, this is kind of what I was showing before, but the other modification I made is that usually you have your application working as node groups. Again, this is the same graphic. I just put a little bit more information here where, sorry, there you go. So in this case, I have 3 different node groups, and this one is only 1 worker node, this one is 2, this one is multiple. So the other thing behind creating node groups is that I want to create a node group for this specific type of workload, and that node group is only 2 cores, 8 gigabytes of RAM. So every time an application needs a new node, right, for that specific workload, is gonna go ahead and grab a node with that specific specification, right? 2 cores, 8 gigabytes. But maybe I have another group where that one requires the node to actually be 16 cores and 64 gigabytes. So that's how, when you say applications are cloud native, this is also part of what it means, right? It means that these applications know and realize how much power is available and how much power they can have access to, and they can take advantage of these node group configurations. So when, let's say, my application is running low on compute power and I need another node, maybe I don't have to go and create a new node with 32 cores and 128 gigabyte of RAM, right? Maybe all I need is 2 cores and 8 gigabytes. So stuff like that is how you do the node groups and how you create kind of these node templates when you need them down the road. And the last slide is, again, why you need Kubernetes, why you need nodes, why you need containers. One thing I wanted to mention is that a worker node, what it really represents is just compute power, and is either a physical or a VM machine. Within this node, that's where you run what's called pods, right? Pods is the way that you group containers in a specific workload. So in this specific case, you see one single worker node running 4 pods. Now, these 4 pods could be using, it could be an entire application that you don't need anything else, or maybe your application needs 2 different worker nodes, and on each worker node, you have, 3 or 4 pods, right? And the way that Kubernetes handle autoscale is that before trying to allocate another worker node to a specific workload, it will try to create more pods on the same worker node. And only when the worker node is running out of power or out of compute power, that's where Kubernetes is going to say, hey, Mr. Application or Mrs. Application, I wanted to scale. This worker node doesn't have any more space, so I'm going to instantiate another VM or another worker node, and I'm going to put that new pod or those new pods on the new worker node. And that's kind of how you handle a autoscale also in Kubernetes. So guys, I'm going to stop right here. I know it's a lot of documentation, it's a lot of information, but I wanted to make sure that everybody gets their feet wet, and you, at least when you're going deeper into these technologies, you at least have some baseline information. So I'm going to stop sharing now, Andre, and you're good to go. And I think you can just grab it. Oh, right there. There you go.
All right. Is it showing again?
Yeah, I can see the screen.
All right. Oh, there you go. Okay, so I want to spend the last couple of minutes just to quickly go over the composition of component pack. And I'm not going to spend a lot of time on the features. You've already heard Renee talk about them. But we frequently get questions, what's in component pack versus what's in the rest of the product? Which pieces of component pack do I need for what capability? Can I skip this or that? And you've heard us say many times now that we want to make it easier for customers to adopt component pack, as well as push down the infrastructure footprint so that it becomes more readily available. So just to quickly reiterate, currently in Component Pack, besides a lot of other things, but the major features are obviously Activities Plus, quick results, Orient Me clearly, and as of 7.0, we now have the Teams integration, we have tailored experience. You've seen a lot of that over the course of the last 2 days. And here on this table, I've tried to list the major buckets of functionality and how they map against a infrastructure requirement that comes with it. I hear that often when I talk to customers, that they think of component pack as a sort of a single entity that can't be sliced and diced. But really, component pack consists of over 100 microservices at this point and has a couple of things that are prereqs to subsets of those services. But we've never done a good job at clearly explaining which sets of services require which other ones to compile a piece of functionality, and which of those require external services, for example, Mongo as a database. So here, this is our first stab at such a visualization. And I quickly want to go through this. I've shown a version of this visualization about a year ago or so, obviously with fewer rows because there was less functionality in Component Pack at that point. And I think what we're going to do is refine this visualization and accompany it with a lot of documentation so that customers can pick which pieces they want. Obviously, at some point, the goal is always for the customer to consume all pieces of Component Pack. But what we're trying to do with an approach like this is to allow a customer to take, let's say, customize a light and just incur the burden of having to run Docker containers rather than having to operate an entire Kubernetes cluster. And then once they've gotten familiar with that, they then deploy Kubernetes. And with Kubernetes, they can now do the full custom, they can now do metrics, PDF export, quick results, right, when they throw Elasticsearch into the mix. And then over time, they start adding Mongo and Redis. And as soon as they have the entire stack, they can deploy the entire set of capabilities in Component Pack. So here you see that there are multiple sort of routes to go through the entire deployment of Component Pack. Previously, customers would always think about only the WebSphere side and then a big leap towards the entire Component Pack side. But now you could think of the WebSphere side, then Docker, then Kubernetes, then Elasticsearch, then Mongo and Redis. Or WebSphere, then Docker, then Kubernetes, then Mongo and Redis, then Elasticsearch. Previously, with connections 6 CR5, I think, we were running Orient Me on Solar. So there was another column in here. But with CR6, we've migrated the Orient Me to Elasticsearch so that you don't require Solar anymore. So we're trying to condense the stack inside Component Pack here so that it becomes fewer components and each component gives you, incrementally more value. So I just wanted to show this, and I'm sure there are going to be a lot of questions about this visualization. You'll see the slides, and as I said, I would really be interested in hearing your opinion on whether that would make it easier for you to adopt Component Pack, and whether that would lead you to a position where you try to really slice and dice pieces and pick and choose which components of Component Pack you want. And then we can start to refine the documentation around how this could work. Ultimately, my sort of vision is that this will result in a much better documentation of what Component Pack truly is, to the degree that we really define each service, with its inner dependencies, which ports does it require, which other services. I mean, all of these things are defined clearly in code, but they're not easily consumable to the administrator at the customer side. And since we're about to run out of time, I want to quickly touch on one last topic that I don't think we've talked about before. Lewis has already spoken quite a bit about Ansible scripts, and internally we are using Ansible scripts very heavily, and we've made an effort to build an Ansible script set that is aiming at automating the entire deployment process of connections. And I think we're at a pretty good point at this point. If any of you have tried the preview, the entire preview server is deployed through our Ansible automation, as well as upgraded through our Ansible automation. And our goal is that we'll release a first version of our Ansible scripts with 7.0, and it'll serve as sort of a reference to how customers could build their own scripts. And here I just try to list all the things that our Ansible scripts cover, right? They support obviously the WAS installation, IHS, Nginx, currently operating systems is Red Hat and CentOS. There's obviously the entire stack is automated, as well as all the plumbing that happens between WebSphere and the database and the node federation, et cetera, the connections install itself, and then the entire Component Pack stack, right? Kubernetes, Docker, Mongo, Redis, Elasticsearch, all the services. And it allows you to either install the entirety of connections or just pieces of it, install a new environment or upgrade the existing environment, scale Kubernetes, and we're also throwing Grafana and Prometheus into the mix. So this is our first version of such a set of scripts. And we're sort of, this is really, I'm really looking for a lot of feedback here because we're trying to figure out what this could be, right? I don't think, I think this is a very, very helpful piece of technology that we should make available with the product. But then again, it also requires a lot of customization in the particular customer environment based on whatever environment restraints they have. So maybe this is something we're going to open source and collaborate with other people on, or maybe we leave it as a reference and just ship an updated version of it with every subsequent release of the product. So please let me know what you think about this. You'll get to play around with it as soon as 7.0 ships. And I think we're doing amazing on time, Wannes.
Yes, you are. Thank you for that. Thanks, Luis.